Welcome to today's webinar, announcing Amazon Athena instantly analyze your data in S3 using SQL. Our presenter today is Abhishek Sinha. Abhishek is a Senior Product Manager for AWS. Today with us we also have Manjit Chayel, Jonathan Fritz, and Jorge Lopez serving as our webinar moderators who will engage with you and answer your questions throughout the presentation while Abhishek presents. Abhishek, welcome. The floor is now yours.
Thank you. Welcome everybody. Thanks for spending the time with us. This is Introduction to Amazon Athena. My name is Abhishek Sinha. You'll find my Twitter handle and my email ID. My Twitter handle is first, my email ID is second. So if you want to interact with me, do send me an email or tweet at me, that's fine. So in today's session, we'll look at a couple of things about Athena. We'll look at the overview of the services, we'll look at some key features. We'll also look at some customer examples. And we'll look at what do we do if your query fails, and we will end with some Q&A. All right, so why did we build Athena? So as you know that a lot of people store their data on Amazon S3, but we realized that there is still significant amount of work required to analyze data that is stored in S3. There are several systems out there that are able to store data directly into S3 in multiple different formats, but you still have to do a whole range of work from ETLing the data, moving the data into some kind of a structure, and being able to write ETL on top of it to actually do any analytics on top of it. So also, when you run analytics, you often have to aggregate the data. And aggregation has its own benefits, but you also have to aggregate the data sets if you wanted to put it into some kind of a data warehouse. So, and this is what you expose to your end users. So users often only have access to aggregated data sets. And there's a wide variety of users who would like to have access to granular data sets. So this was a problem. If you were to access granular data sets, you would have to do something different. There are several big data technologies out there that are really interesting in terms of how they can process data. However, managing some of these technologies is a challenge. You still have to have expertise in how to upgrade these systems, how to use these systems, and how to maintain, for example, user concurrency, how to respond to them, several things. So managing a Hadoop cluster or a data warehouse still requires a ton of expertise. So some of these things motivated us to build Amazon Athena. So what is Amazon Athena? So Amazon Athena is an interactive query service that makes it easy to analyze data directly from S3 using standard SQL. So let's walk through a couple of features. So Athena is serverless. That means there is no infrastructure, no instances, no administration required, or no software upgrades required. There is no infrastructure that runs in your account. You talk to Athena using an endpoint or using the console. There is zero spin-up time. That means as soon as you log in, you're ready to submit queries or analyze results or create tables. What it also means is all the upgrades that happen behind the scenes are transparent to you. You get the benefits of the upgrades without any downtime as soon as they happen behind the scenes. Athena is really easy to use. As I said, you can you log into the Athena console on your AWS management console. You can also talk to Athena using a JDBC driver. You start by creating a table on data that is sitting in S3. You can either use a wizard or you can also use the query console and write a complete DDL statement on the query console, and you can just start querying data. I'll talk a little bit about this in detail as we go forward, but essentially there are two steps to start querying data: create a table and start querying data. Athena is highly available because you talk to an endpoint, you talk to a service endpoint, or you log into the console. So we use isolated warm compute pools across multiple availability zones to service our queries. That means even if a complete availability zone goes down, we'll still be able to service your queries because your data is still residing in S3, which gives you a high amount of durability, and we will be able to process those queries as well. So you don't need to build a DR for Athena. You don't need to have a DR policy in Athena as well. With Athena, one fundamental structural difference is that you can query the data directly from S3. There is no loading of data required into any kind of a data warehouse or anything else. So you can query the data where it lives. If your data lives in S3, just query it directly. You can query data in its raw format. For example, if your data is produced as text, CSV, JSON, web logs, AWS service logs, you'll be able to query data in these formats. You will also be able to query data if your data is in optimized columnar format, such as Apache ORC or Apache PARQUET. If you do query data in columnar formats like ORC and PARQUET, it'll give you the best performance at the lowest result, at the lowest cost. With Athena, Athena does schema on read. That means there is no ETL required. When you define the schema at the time of creation of a table, only the metadata is defined. That means you can keep your data in S3 and just define your schema in Athena. And the schema is applied to the data as and when the queries are run. So you essentially don't require any ETL. For example, if you have a text file that requires a complex regular expression to parse the text file, you can define that regular expression as a part of creating the tables. So there is no ETL required to process the data. You can process data in the rawest format that it arrives in S3. You can stream data directly from S3, so there is no intermediate storage where we are storing the data. It's directly pulling data from S3. And by using S3, it gives you the advantage of the durability and availability that S3 gives you across AWS. So Athena supports ANSI SQL, so you can write full ANSI SQL compliant queries. That means you can do complex joins, nested queries, or windowing functions. Here's an example of a PPCH query. So it's a fairly complex query. It does a couple of it does a write out join. It does a couple of nested queries. You can do that with Athena. Athena also allows you to define complex data types, such as arrays and structs. So if you have data that is in nested formats, such as nested JSON, you can easily use structs and arrays to define schemas on top of the data. You can also partition your data, and you can partition your data by any key that you would like. So essentially just not date time, which a lot of people would want to partition their data by, but you can do date, time, customer key, or anything else. You can also split it as year, month, day, hour, customer key, use all or some of those or a combination of those. So it allows you to flexibly partition data as well. Now there are a bunch of open source technologies which are familiar to a lot of our users that are used underneath Athena. So for running SQL queries, we use Presto. So Presto is an in-memory distributed SQL engine, came out of Facebook. It's ANSI SQL compliant and also gives you a lot of extensions. You can also, when you're creating DDL statements, for example, to create the table or to drop a table or to create partitions, that's when you use Hive. And remember what I said earlier, you can write a fully compliant Hive DDL statement directly from the Athena query editor, and that should work. Take a look at the Athena documentation to figure out what queries, what DDL functionalities is supported and what's not supported at this point. We used Hive for DDL functionality because of a couple of reasons. First, it supports data partitioning by multiple keys, which is really useful. If you're going to use S3 as your data lake, so as to say, then you want to partition your data by certain keys so that you can restrict the amount of data that a particular query scans, thus improving your performance. It also allows you to query data in multitude of formats. That means JSON, text, compressed files, ORC, and PARQUET. So you can create tables on data sitting in PARQUET or data sitting in JSON, and you can even join those tables. And it also allows you to, as I said earlier, define complex data types. You can also run these technologies on top of EMR or EC2. So if you're looking to prototype something, that's also a possibility. So as I said, Athena allows you to process data in a multitude of formats like CSV, raw logs. So for example, logs from ALB or ELB, or Elastic Load Balancers. You can use Apache Web Logs. You can use tab-separated files. You can use JSON, simple and nested JSON. You can also compress your files, and Athena will be able to read them. You can also use columnar formats, the open source columnar formats. And the reason we chose these formats was that a lot of our customers have multiple independent stacks, and all of them can read data from S3. For example, they might have an EMR stack where they're running Spark for large-scale ETL, or they might have a stack where they're running Drill. For all of these, the data, you can store the data in S3, and because Athena also is able to read these open source formats, it allows you to interop between these different stacks and keep your data in S3. So today we don't have Avro support, but that's also coming soon. In Athena, so watch out for that. So Athena is fast. It's tuned for performance. When you submit a query, we automatically parallelize the queries across several cores. Results are directly streamed onto the console, but results are also stored onto an output bucket that you can customize on S3. So if you look at the Athena console, there's a settings tab on the top, and if you drop down the settings tab, you can see the base S3 directory where results can be stored. You can improve your query performance if you compress your data or you use columnar formats. Both of these allow us to scan less data, and when we scan less data, Athena is faster. Athena is cost effective. It's a very simple pricing model. It's a pay per query pricing model, so there is no upfront cost for Athena. If you have data sitting in S3, you just pay S3 rates for those data, and if you don't run any queries, you don't pay for Athena. On a per query cost, the charge is $5 per terabyte scanned from S3. We don't charge you for DTL queries or queries for loading partitions or failed queries. Those are all free. But if you do cancel a query while it's running, we will charge you for the amount of data scanned. So an interesting point to note here is that if you compress your data or change it into columnar formats or partition your data, that means you scan less data and your costs subsequently go down. So who is Athena for? So if you're looking at processing data stored in S3, Athena is a good use. Athena will be a good fit for you, and you can have data coming from a multitude of devices, or from Apache Web Logs, Omniture Logs, CloudFront Logs, application logs. You can have data coming from multiple different formats, and you'll be able to process data in Athena. Anybody who understands SQL, so both developers and analysts, will be able to process data with Athena. You can also use Athena for ad hoc exploration of data and for data discovery. And of course, if you're building a data lake with all your data sitting in S3, you will be able to use Athena to provide access to all your developers or all your analysts by allowing them to run queries on data sitting in S3. So here's a sample pipeline that a lot of our customers currently run if you're running on AWS. And I just wanted to add Athena to it and to show you where Athena kind of fits into with other products. So several of our customers land data in S3 from different data sources. They may use EMR for transforming or cleansing the data, or for some sort of ETL, for machine learning, or for other tasks like creating views of the data. This data is subsequently loaded into Redshift, and then you can use a BI tool like Amazon QuickSight to visualize this data. So Athena can fit in here, where you can just run ad hoc analysis on data sitting on S3 using SQL, or Athena will also be able to access the formatted or the cleansed data if you wanted to do so. Athena also integrates with QuickSight, so you'll be able to use QuickSight to directly visualize the data on Athena. So let's revisit what we said about Athena, the challenges. So we said that there was significant amount of work required in analyzing data from S3. But now, as you can see with Athena, there's just no ETL required. There's no loading of data. You have your data sitting in S3. You can just create a table and query the data. And you query the data where it lives. With Athena, you can give users granular access to the data at whatever granularity you like. If you wanted to cleanse the data and provide a view of the data, that's also possible. And with Athena, there is no infrastructure to manage, so no expertise required to manage systems. All of that is done underneath the hood. All right, so let's look at the console. So I'll switch to my console. So here's the Athena console. It's fairly simple. It's a fairly clean interface. So you can see that there is a query window. You can write queries here. On the left-hand side, there's something called databases. This is not a database in a traditional sense like an OLTP database, but it's essentially a collection, a logical collection of tables. You can create a new database. There's some restrictions as to what names you can choose for those databases, so you can't have special characters in those databases. So look for the Athena documentation as to what is available. And inside each databases, you have several tables. Each of these tables, for example, has some columns defined. You can look at the columns. You can also look at where this data is stored. So you can see that this data actually comes from the examples database. You can also see when it was created, what was the input format used. So you can see a bit of table properties on this data. So you can also filter through tables. Remember the settings tab that I was talking about? Here's the settings tab. So for every result, every query that you run, every successful query that you run, the results, for example, are stored in this particular directory, and you can change it or this particular prefix on S3. Be careful about using a bucket that is in your own region. If you're using Athena in US East, try and use a bucket that's in US East. There's also an ability to save a query. So, for example, you can see that for my demo purposes, I have saved a couple of queries. I can click on these queries, and these queries will go back, and I can just use them. There's a history view. You can see the queries that you ran. From a history perspective, you can search through this. And each query also tells you how much time it took, how much data it scanned, and it allows you to go back and download the results. So if you click on a query, let's say, for example, let me click on this query. So it takes you back in time as to what that query was, and you can look at the results as well. Now, if you do have queries that are failed, so I might not. Let's see if I have some. Yeah. So I have a query that this failed, so I can look at the error details as well. You can look at the query ID as well. So all of these are available in the history view. Then on the left side, so I wanted to talk to you a little bit about this. So this is a metadata catalog. It's currently managed by Athena. So when you create your tables, the metadata goes and gets stored in this metadata catalog. You can go to the catalog manager, and you can also browse through this catalog, or you can talk to the catalog using DDL statements. So it's fairly simple to talk to the catalog. All right, so let's run a couple of queries. So I'm going to go to my saved queries, and I'm going to pick up a couple of. So if you're logging into Athena for the first time, you would also see that there are a bunch of queries that we already populate for you. So there's a CloudFront table. So these are used to process CloudFront logs. So you need to first create the table, and then you can do a select query on that. There's some ELB logs. There's a flights data set. This is in PARQUET. Remember, this is a partition table, so you will need to load all your partitions in here, and then you can create or you can run some queries on this table. So just some sample queries to get you started. Right. So let me take this query. So what this query does is this is a simple query that is that's essentially creating a table on this location. So all my ELB log files are actually sitting in this location. And it creates, I have a table, made sure that the name of the table is new. It's not something that I have here. And you can see that it's really simple to be able to define columns like everywhere else. So in this case, now these three statements are the interesting ones. These three statements, if you're familiar with Hive, they will look very, very familiar because they are using HiveQL when you are writing DDL statements. Remember what I said about Athena, that Athena uses Hive for DDL statements and Presto when you're running queries. So you can write HiveQL for your DDL, but then standard SQL or ANSI SQL when you're querying the data. So in this case, it's basically saying that I'm going to use something called as a SERDE. A SERDE stands for a serializer or deserializer. So basically, this is a parser that is looking at looking at your data and is parsing it the way you want to. So in this survey, I've given it a regular expression, and this regular expression corresponds to how I want to parse this particular file. And you can see that the location points towards a prefix. So I have several files in this prefix. And when I actually run the query, so let's go ahead and run the query. When I actually run the query, yep, so here's another trick. Don't try to, if you highlight something, that becomes a query. You probably want to not highlight something. So because that's what you selected. So I was selecting location, so it gave me a no viable alternative error. But pretty simple. So now, as you can see, I ran a query. Here's what it appears on my catalog. I can now essentially just click on the eye icon. That's basically a simple query that runs on this data set. Now this data set, and here you go. You have data. You're able to query this data. You're also able to download these results, right? So you can download this result sitting on S3. So here you have the CSV file that you can download these results into. Now, the backend for this, in the sense where the data is actually stored, is just text files, right? So it takes a bit of time to be able to run these queries, right? So in this case, let me try and run. I'll try and run another query on this. But what I also wanted to create was, let me also create a table which is in columnar format. And in the end, what I want to do is I want to actually run a large query on this table that will scan the entire table. So in this case, I have about roughly 1 terabyte on this table. So when I use this, you can see I have just text files. So I have the text input format that I use. I will also create a table on the Parquet input format, and you would see that the difference between running queries on text format versus running queries on the Parquet format. So let's go ahead and do that, right? So go back to save queries. I'm going to take, here's my create table, which actually creates the data in Parquet format. You can see I'm going to add a word demo here so that it doesn't collide my existing tables. Pretty simple. Here, what I've also done is I've also partitioned this data. So in this case, I'm partitioning this data by year, month, and day. So this is 3 levels of partitioning. That means I can use these in my where clause. So I can say where day is equal to something, where month is equal to something, or year is equal to something, or all 3. And in this case, these are, by the way, these buckets, the ones that you see, Athena examples, ELB, Parquet, these are all public buckets, so you can actually experiment with this data. We wrote a blog post, so here's the blog post on the AWS Big Data blog on analyzing data in S3 using Athena. So all the data that I'm showing you today is actually available. All the queries are available, and you can just run these queries if you want to get a feel of the system. Right. So in this case, this looks slightly different, right? It doesn't have a regular expression. It's basically data is stored in Parquet format, and I have some schema, the same schema that I defined in the previous table. One thing to note is in both of these tables, I use the keyword external. Now the external keyword tells Athena that the data is sitting on S3, and if I drop this particular table, the data does not get deleted, and that is very important. So Athena only allows you to use external tables at this point of time so that you don't accidentally go ahead and delete your data. That means I can create multiple schemas on the same file as well. Right. So let's go ahead and run this. Now remember that I defined I defined this with partitions, right? So one thing that I've seen customers do early on is when you partition, think of these partitions as columns, right? So that means if I'm defining these partitions like year, month, and day, I don't need to repeat them here. They become a part of my table. That's why I can use them as in a where clause. Also, as you can see, my table is created, and the table is created so fast because we're just creating the metadata. No data has been moved and no data has been touched. But here, Athena tells me that this query was successful, but if your table has partitions, and I need to load the data into partitions, Now, fortunately, my data is in a format that is automatically understood by Athena. So I'm going to load all of them. Instead of loading them, I'm going to load all of these partitions. So I'm going to say MSCK repair table, and I'm going to type in my table name. So ELB logs PQ in this code demo. Now this will take a while because there are several partitions on this. I think I have a year worth of data, so it's lots and lots of partitions. So I'm just going to run this query. It's going to take some time, but what I'm going to do is so that I don't block this console, I'm going to just hit new query, and this query automatically goes into the background and runs underneath the hood. So you can see that right now this query is running. I can go ahead and cancel this query, but that frees my editor to go ahead and use, for example, run a different query in here. So I'm using the ELB logs. So we'll come back to this in a while because it's going to take some time to load the partitions. We will see when it loads the partitions. So let's switch back to the PowerPoint. I hope you got a feel of what the console looks like. All right. So the console is not the only way to access Athena. You can also access Athena using a JDBC driver. So look through the documentation. There's an Athena JDBC driver, and for using your username, before I go there, if you observe, there's a region-specific URL in the JDBC driver. So be a little careful about what region your data is in and what region you were using Athena for. But for example, in this case, you're using SQL Workbench. The username and password that you use are the secret key and access key for an IAM user. So make sure you have them, and that's what you'll need to authenticate to Athena. You'll be able to browse through tables. You'll be able to run queries, similar, just like you do it on the console as well. We will also look at using Athena with QuickSight. So you would see that integration come pretty quickly, possibly in a couple of weeks. So the way it will work is Athena will be one of the sources. For example, in your QuickSight interface, you will create a data source name. So in this case, this would be a name of a table, or excuse me, this will be a name of a table or a database. And once you do that, you will see that all the data inside the table will be ready for you to visualize. You have two choices. You can either import this data into Spice, or you can directly query your data using Athena. In this case, we'll try directly querying our data, and then you'll be able to visualize. So for example, the flights data set that I showed you, which is already available for you to query, it's not a big data set, but it's good enough to play with. You'd be able to play with that data set, and you will be able to create visualizations on this data set using Athena, with all your data sitting in S3. All right, so you can also use the JDBC driver for programmatic access, and if you look through the docs, you will see you will see examples of that. So it should be fairly simple to get this. For example, to set up a connection, this is what I'll need to do: 5-6 lines of code to be able to set up a connection, and then you can you can just issue queries. So in this case, you can issue queries, for example, a create table statement. Remember, don't forget adding the external keyword, and you can essentially just run queries on this data set. So let's talk a little bit more about creating tables and querying data, because those are only two things you need to worry about when you're using something like Athena. Right, so when you're creating tables, you can write a complete Hive DDL statement. So you can look at either the Athena documentation or the Hive public documentation. We chose Hive because Hive gives you a high degree of flexibility in choosing different types of data formats, in choosing different types of partitioning keys. That was really useful for a lot of our customers. Also, a lot of our customers are familiar with Hive and have data that they have stored in S3 that can be read by Hive. So onboarding them on top of Athena is fairly simple. You would need to also, Hive also does schema on reads. I talked about this a little bit earlier, where when you create the metadata, the metadata is just, when you create a table, the metadata is just sitting in Athena, When you actually run the queries, that's when the metadata is applied to the data. We talked about external tables a little bit. We talked about the different formats. We talked about surveys. Currently, there are about 6 or 7 surveys that are available for Parquet, ORC. There are 2 for JSON. There's 1 for regular expression, and then there are native surveys that are supported by Hive. If you do need different surveys, do let us know, and we'll try to add it into the system. You can't bring your own survey at this point of time. So the metadata store, I talked about this, but one thing that is important to note that it contains table definitions, column names, but it also has partition data. So we'll show you that maybe at the end of the presentation. It requires no management. And if you use an EMR kind of environment where, let's say, you're running Hive and you're running Presto, the metadata store works exactly as the Hive metastore. It's very, very similar. So you can, if you have an existing Hive metastore in your environment, you can take the same DDL statements and run on Athena, and Athena will be able to use those DDL statements in its own metastore. So both your Hive metastore and Athena's metadata store will coexist. Running queries is simple. I showed you, you know, how you can run a couple of queries. Here's a complex query that you can run. We show you the runtime, and we also show you the data scan, right? So this is scanning roughly about, 12 gigabytes of data. So we charge you about $5 a terabyte. So this will be roughly 1/10 of that cost. But looking at the data scan, you can easily estimate what did this particular query cost me. Now, the 2 columnar formats, which are pretty prevalent in the industry today, Apache ORC and Apache Parquet, both of them provide a high degree of compression. Both of them support predicate pushdown, and Athena supports both of them. So if you have data that is in ORC or Parquet, you'd be able to easily use Athena to process that data. Now, converting to ORC and Parquet is going to give you benefits both in terms of cost, but also in terms of performance, and we'll see this in the queries that we run. So you can use several things. So Athena does not automatically convert this data from text formats to Parquet format or ORC format. Athena gives you a choice whether you want to run on text or ORC. But there are several tools out there that will help you convert this data. For example, you can use Hive, and you can use a CTAF statement on an EMR cluster to convert this data. You can also use Spark. And we put out some code, for example, on GitHub. You can find the link at in the presentation, where there's 20 lines of PySpark code running on EMR that can convert data in text files into Parquet files with snappy compression. So an example is the 1 terabyte or 1.15 terabyte of log files that you see me using in the demo today. When I use this PySpark code, it converts it into 130 GB of Parquet files. That costs me about $5 to do that conversion. Conversion has benefits. I'll show you this, when we run the queries. But take a look at this example. This is the same example on the same log file that we just saw. So when I process a text file, and you can look at the query on the top, it's a pretty simple query. It's got a nest in it, but that's it. So, but it is scanning the entire data set. When I store data as text format, every query is going to scan the entire text. So, for example, in this case, unless I have partitions, the only way I can have the query scan less amount of data when I'm using text files is to use partitioning of data. So in this case, this query runs for 237 seconds because it is processing data directly from S3 in its raw text format. It scanned about 1.15 terabytes of data and cost me $5.75. When I convert this into Parquet, the same query on the same data set runs for about 5 seconds, scans 2 GB of data, and costs me less than a cent. So that's very powerful. in terms of, if you do decide to convert the data, you'll get advantages in terms of cost and performance. So let's switch back to the console before we go into the use cases. So as you remember, when we ran some queries, so you can see this was the query that we ran. It used to load all the partitions. I can go back into the query editor and I can show you show partitions. Sorry for my alerts. UOV logs PQ_demo. I think that's the one I used. Right. So if you run, you can see that all the partitions will be available, and it's a lot of partitions. So you can see that I have partitions for each month, each day. There's several of them, and it has loaded all the partitions. So all an year worth of data is now loaded in partition, and I can now query this data. So for example, let me go back to that query that I ran. So here's the query. It's basically scanning everything, but I can add a where clause in here. Let me make sure that I have the name of the table right, and I can just run this query, and this query will give me results pretty quickly. Remember, if you hit the new query button, this query will go into the background, and you can go back into history and check this query. So for example, this query roughly took about 10 seconds to run, scanned about 2.5. Remember, this scanned 2.5 GB of data. That doesn't mean it processed 2.5. It processed probably much more, but it scanned roughly 2.5 GB of data and gives you the result pretty quickly. I can go into history, and remember, I can go back and look at these results, and I can download these results as well. I can go back. So this was the query that ran for 1.5 on the entire data set, and you can, if I click back on it, you can see that it actually was running on raw text files. So it gave me the same result, but it took a really long time to run. Not bad if you're using text files and data is just sitting on S3 for that, but you can get the benefits of performance if you decide to convert data into Parquet or ORC. All right. So let's switch back to the presentation. So let's look at a couple of use cases. Right. So before we look at use cases, there's a wide portfolio of AWS products that you can use. You have Amazon S3 as your central source of truth for all your data. You have Amazon Redshift, which is the petabyte scale data warehouse. You have Amazon EMR, which can run the latest big data applications on top of it, and you have Athena, which is a query service. And then you have QuickSight, which is a BI engine that can be used for visualization. Now, if you have data warehousing needs, and if you Redshift is probably the best use case for that. So all of these three systems don't kind of collide with each other; they complement each other. If you have schemas and want relational integrity and want to get the fastest performance, I would use something like Amazon Redshift. If you want to use the latest big data applications and a wide variety of applications, and want to have full control over instances and want to be able to configure anything on your cluster, I would want to use EMR. And if you would like to just query data from S3, that's where Athena comes into the picture. So we have seen people use all of these four systems along with S3 in a wide variety of configurations. They're all purpose-built tools. You can use one or a combination of those for your use case. So we were fortunate to have several customers try out Athena when we were in a private beta, and when we launched, a lot of these customers were already in production or were running a large workload on top of Athena. Several of them gave us those references. You can learn more about those references on our website as well. But here's an example from DataZoo. So DataZoo is a real-time bidding and a retargeting platform. They process roughly about 180 terabytes of log data per day, significant. They pipe this data into Kinesis, and they run large EMR clusters They use Spark SQL, they use Spark machine learning for attribution and preparing this data set, and they push this data set into S3, where in turn they use Amazon Athena, so that this data is opened up to all their analysts and within the organization for them to be able to query it. And they don't have to manage any infrastructure, they don't have to manage concurrency, they don't have to manage scale. So as always, we're very humbled by how quickly our customers look at adopting these technologies. So find it exhilarating to look at how customers are using this. So we had released Athena on 30th November at 10 o'clock, and at 10:24 we got a tweet that somebody was up and running on Athena querying production logs from S3. Thank you very much for the tweet. Appreciate it, but just wanted to show how easy it is to get started with Athena. All right, so let's try and look at a couple of tips and tricks or troubleshooting techniques if your queries do fail, or what are the common things that we see customers run into. First is, when I created a table, but I don't see any data, what's going on? So Athena uses schema and read, as I said earlier, right? So when you create a table, it's just creating metadata. Not till the time you actually run the query, the schema is applied to the data at the time of running the queries. So there are a couple of things. Verify that your input location that you use in your create table statement is correct on S3. So if you're using a root bucket like S3 name / make sure that you have the / at the end of the root bucket. Or if you're using anything else, make sure you have that properly specified. If you specify a bucket with a fully qualified name, like the one is in the second bullet point, like US East 1. Amazon AWS, that'll throw you an access denied error. So the right format to put your S3 buckets is S3 bucket path ended with a / Athena can only create tables on buckets. So every other file that you have inside that bucket becomes a part of your table. If you add new files to that particular prefix, that will also become a part of the table. Sometimes, for example, you saw me create a table in PARQUET dataset, and I had to go and load all the partitions. So sometimes, if you're not seeing any results out of your tables, make sure that if you did define any partitions, did you go and run MSCK repair table? So if my data is in the format that's it's shown in the first example, S3 my bucket key and a value. For example, in this case, I have partitioned my data by year. So year is equal to 2016, year is equal to 2015. If my data is in this format, I can use MSCK repair table to load all the data, all the partitions. If my data is not in this format, for example, is in the format that you see second, S3 my bucket input data 2016, then I can use alter table add partitions like the way I've shown to add those partitions manually. So remember, if you define partitions, you have to first load the partitions for you to see any data. So if you have data coming in on an everyday basis, you can define the partition. You will need to do the metadata query first. That means you need to say alter table add partition first before you can see the data in that partition. So make sure you're aware of that. So also another thing that we see customers do is when you define your partitions, make sure that the partitions, whatever you define as partitions, is not repeated in your create table statement as columns. Your partition acts as a virtual column. For those of you who come from a Hive background, you're probably familiar with this, but here's an example. So what's on the left-hand side is correct. What's on the right-hand side will throw you an error. A lot of people have data, a lot of our customers have data that is in JSON. We have two JSON surveys. There's the OpenX survey, which you can see, which is an open source survey. You can see it online, and there's the native JSON survey that you can use to query your data. The couple of things that you need to note: make sure that your JSON record is a single line. Make sure you generate data in a case-insensitive format. So, Athena uses case-insensitive column names. So if you have two column names, which is they have the same spelling, but one has caps and the other doesn't have caps, we will report those as duplicate partitions. Also, if you use the OpenX array, you have an option to ignore malformed records. So if you see the example in red, which says with survey properties, ignore malformed JSON is true. If you enable that, that will be useful in case you have malformed JSON that is not allowing you to read the data correctly. If you do see access denied issues, make sure you have the right IAM policy. Refer to the getting started documentation on what that policy should look like. But the IAM policy is not going to be enough. You also need to have your bucket ACLs or the access control list for your buckets that allow you to read from your source bucket and write to your output bucket. So if Athena gives you an access denied error, make sure you look at both of these things. If you have enough policies to get started, and if you have the access to both the read and write bucket. Table names. So there are some. If you have table names that start with an underscore, or if you column names that start with an underscore, you can backtick them for you to use them in Athena. And table names can only have underscores as special characters. So if you're going to use table name dot something dot something dot something, that's not going to be accepted as a valid table name. So just make sure you know about that. So we come to the end of our presentation. Hopefully we can answer. I'll take a look at questions and we can answer those questions. But hopefully this gave you an overview of why we built Athena, the features that are available in Athena. You can look at the getting started documentation. You can also look at the big data blog, which I would highly recommend for you to read, not only for Athena, but for other big data technologies that came out of AWS. If you would like to send me an email, ask me a question, that's my Twitter handle, and that's my email ID, so feel free to do so. I appreciate the time that you spent today. I appreciate your attention. Let's start with some questions.
Great. Thanks a lot for a great presentation, and to the moderators for answering the audience questions. We have about 12 minutes left, so we're going to start taking some questions that have come in, and we apologize in advance if we don't have a chance to get to all of them. Please take a quick minute to reply to the polls you now see appear on your screen. Thank you.
All right, so I'm just going to read the questions and then the answers. Okay. So Alex says, can you create Athena tables using JDBC Driver so you could dynamically create tables that query the data from a Lambda function? Absolutely, you could do so, Alex. In fact, I think you have some code examples, not really related to Lambda, but how to programmatically use the JDBC Driver in our getting started documentation. It's linked under using the JDBC Driver. Can save queries be shared with others from within the Athena interface? Not at this point, Brian, but thanks for that feedback. How much history is by default retained? Can this be configured? So I think we have 100 queries at this point of time, but I'll have to look into the documentation to figure out what is the total number of queries. But I think on the console, you can go back a couple of pages to about 100 queries. So Eric says, is the schema populated once or S3 continuously polled for new data? Or do we need to truncate and refill? That's a great question. So the schema is just metadata. The schema is applied to the data. And when you create a schema, you are specifying the schema. You're specifying the location as a prefix. So everything that you have inside that prefix becomes a part of the table. So every time you run a query, that's when the schema is applied to the data. So don't think of it as a schema getting populated from data in S3. It's a schema on write, which is slightly different. You take the schema and you apply it on the data. So let's say on day one, I have two objects in prefix in S3, and I've defined the table on that. So my table will have all the data that is within those two objects. On day three, if I added a third object and I ran a query, it will grab the new object and it will show you all your data. However, this changes when you have partitions. When you have partitions, and if you have a new partition, you have to tell Athena that there is a new partition. You can do so by saying alter table, add partition, and give it a location. That location is also a prefix. So even if you have data in the prefix, Athena will not be able to see that unless you tell Athena that there is a new partition. So Anil says, are there ways to determine Athena cost incurred by different user roles? I'm not sure. I think we'll need to do, I think you get a consolidated bill, but I'm not sure about that question, Neil. Maybe I can take back the question and work back, but I think the answer is no at this point of time. Nathan says, when you partition data based on document contents, is that metadata pre-stored somewhere for Athena? Is that data read every time from the documents? AKA, on a practical side, are we paying for data scanning that results in partitioning data out of our query? When you create partitions, so if you load partitions and create partitions, those queries are not charged. Only when you run queries in the partitions, those queries are charged. When you partition data based on document, yes, the partitioning information, metadata, is stored in the catalog. Is it possible for me to switch back to the to my screen? Yeah, let me show you this. So we used, I think, sample DB, and I think I used this Parquet table. And when you look at this Parquet table, you can see that we also have partitions here, right? So the partitions are stored in the metadata folder as well. All of this information as to all the partitions, as to what is the name of the partition, where is the location of the file, is also stored in the metadata. That's why if you have a new partition, you need to tell Athena by using an alter table command that a new partition has is there. Ross says, can a query result be saved to a specific known location in S3 so that they could be loaded into Redshift or used for further analysis? Yes, so you can store location. You can do that if you go to the settings tab, and there's something called query result location. So it's a global property. That means all your queries will get started, all your query results will actually will get saved here. So you can do so. Kurt, hey Kurt, where is the Hive catalog data stored? Is the catalog data accessible as a service? So currently the Hive, the catalog data is stored in this metadata catalog that you see here, that is stored within the service. It's distributed by default, so you don't need to back it up. You don't need to do anything to manage that. It's a completely managed interface within Athena. You can interact with it either using the catalog manager or using DDL queries. So Cristobal says, is it possible for it to use Athena for extract data in real time? I think we need to qualify that answer a little more. If you have data sitting in S3, could you immediately query it? Yes. If you have data coming in a stream, could I use Athena to query data in a stream? No. You probably want to use something like Kinesis Analytics for that kind of queries. Matt says, is Athena supported in the Boto library? If not, what is an ETA? Unfortunately, at this point of time, it's not. I don't have an ETA on that as yet, but we're working on it. Can EMR, Hive, and Athena share the same metastore? Muthu says that. No, not at the moment. The Athena metastore is independent from the Hive metastore that you might use with EMR. They don't collide with each other. That means you can run the same DDL statements on Athena pointing towards the same data set. But currently, both of these metastores are independent of each other. Mary says, so is Athena more for querying the data for reporting purposes? The data doesn't go to data warehouse. Could you provide a use case? Sure. You could use Athena for querying purposes if you pipe it behind a BI tool like Amazon QuickSight, where you don't need a data warehouse. There are pros and cons of that. In a data warehouse, you ETL the data into a schema and you build it for relational integrity. So all of those things are not available in Athena. But yes, if you wanted to build a report that runs queries on data sitting in S3 using a BI engine, you can definitely do so. Can you trigger a stored query from Lambda C#? I don't know the answer to that at the moment, given that Lambda just released the C# support. Well, thanks for the question, Mike. I think you might not be able to do so today, but I'll investigate. So that looks like all the questions. Let's see if there are any more questions. A couple more. Okay. So I think I answered this, so let me just scroll down. Stephen says, it would be very helpful to allow partitioning for a fixed folder in S3 that does not have the key value format as a name. For example, S3 bucket dir 26 support rather than S3 bucket. Yeah, so if you, so Stephen, you could do that. You could do that if by using an alter table add partition command. So for example, in your bucket, let's say you partitioned your data by date. So I would say alter table add partition date is equal to 2016-12-01. Location is equal to S3 bucket dir 2016-12-01. So that will automatically create a partition with the value 2016-12-01 and point to the location that you have here. So the only benefit of having the format like dt is equal to 2016-12-1 is that if you have a large number of partitions, MSCK repair table can automatically go and get those partitions. You don't have to manually load all of them. But you can easily add these partitions. So just to reiterate my point, can I go back to the presentation for a second? Right, so let me go back to the slide. So take a look at this data, Stephen, right? So this particular folder has year is equal to 2016. Now this is D key is equal to value format, and you can do MSCK repair table. However, this folder is not in that same format, but I can still add partitions by using alter table employ add partition. Year is 2016, and location is this particular prefix. Remember, it's the prefix and not the file. Our partition is this, and this is the prefix. So I hope that's clear. All right. So do we have time for more questions? All right. So seems like we got a wrap. Sorry if I couldn't answer your questions. Please do send me an email, and I can answer those on email.
Awesome. Thanks a lot for a great presentation. And again, we apologize if we did not get to all of the audience questions. If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS will cover in future webinars, please drop us a line at aws-webcasts@amazon.com. Your feedback will help us to improve our webinar programming. Thank you for taking the time to join us today, and just so you know, we will be saving a copy of the Q&A log for review after the fact. So again, we apologize, we did not have a chance to get to all of your questions. Enjoy the rest of your day.